Welcome. Today we're diving into the fundamentals of model fitting, a cornerstone concept in data science and machine learning. Whether you're new to the field or looking to refresh your knowledge, understanding model fitting is essential for building predictive models that actually work. In this video, we'll break down what model fitting means, why it matters, and how it forms the backbone of many analytical processes. Let's start by exploring the basic idea behind fitting a model to data and why it's such a critical step in any data-driven project. Model fitting refers to the process of finding a mathematical function or model that best describes the relationship between input variables and output variables in your data. Imagine you have a scatter plot of points. Model fitting is like drawing a line or curve that best captures the trend of those points. This process helps us make predictions, understand patterns, and extract insights from complex datasets. The better the fit, the more accurately your model can predict new, unseen data. Why is model fitting so important? Well, it's the foundation of predictive analytics. A well-fitted model can help businesses forecast sales, scientists predict outcomes, and engineers optimize systems. Without proper model fitting, predictions can be wildly inaccurate, leading to poor decisions. That's why understanding the basics of model fitting is crucial for anyone working with data. It's not just about drawing lines, it's about making reliable, data-driven decisions. There are many types of models you can fit to data depending on your problem. Linear models are the simplest, drawing a straight line through your data. More complex problems might require polynomial, logistic, or even neural network models. Each type of model has its own strengths and weaknesses, and choosing the right one is a key part of the fitting process. As we move forward, we'll look at how these models differ and when to use each. For fitting any model, it's essential to understand your data. This means looking at the variables, checking for missing values, and understanding the relationships between features. Good data preparation ensures that the model you fit will be meaningful and accurate. Remember, even the best model can't compensate for poor data quality, so always start with a thorough data exploration before moving on to model fitting. Common practice in model fitting is to split your data into training and testing sets. The training set is used to fit the model, while the testing set evaluates how well the model performs on new, unseen data. This approach helps prevent overfitting, where a model performs well on training data but poorly on real-world data. By splitting your data, you can get a more realistic sense of your model's predictive power. Overfitting happens when a model learns the training data too well, capturing noise instead of the underlying pattern. This means it performs great on the training set but fails to generalize to new data. Overfitting is a common pitfall in model fitting, especially with complex models. Recognizing and avoiding overfitting is key to building robust, reliable models that work in the real world. The flip side, underfitting occurs when a model is too simple to capture the underlying trend in the data. It might miss important patterns, leading to poor performance on both training and testing sets. Underfitting usually happens when the chosen model is not complex enough or when important features are left out. Striking the right balance between underfitting and overfitting is a core challenge in model fitting. Key concept in model fitting is the bias-variance trade-off. Bias refers to errors from overly simplistic models, while variance refers to errors from models that are too complex. The goal is to find a sweet spot where both bias and variance are minimized, resulting in a model that generalizes well. Understanding this trade-off helps you choose and tune models more effectively. Selecting the right model depends on your data and the problem you're trying to solve. Sometimes, a simple linear model is enough. Other times, you might need something more sophisticated. It's important to experiment with different models and compare their performance. Tools like cross-validation can help you make informed choices and avoid common pitfalls. Once you've fitted a model, it's crucial to evaluate how well it performs. Common metrics include accuracy, precision, recall, and mean squared error depending on the type of problem. Evaluating your model ensures that it's not just memorizing the training data but actually learning patterns that generalize to new data. This step is vital for building trustworthy models. Visualization is a powerful tool for understanding how well your model fits the data. Plotting the predicted values against actual values can reveal patterns, outliers, and areas where the model might be struggling. Visual tools help you communicate results to others and spot issues that might not be obvious from numbers alone. There are several popular algorithms used for model fitting. Linear regression is one of the simplest and most widely used. Logistic regression is great for classification problems. More advanced techniques include decision trees, support vector machines, and neural networks. Each algorithm has its own strengths and is suited to different types of data and problems. Loss function measures how well your model's predictions match the actual data. During model fitting, the algorithm tries to minimize this loss, improving the model's accuracy. Common loss functions include mean squared error for regression and cross-entropy for classification. Understanding loss functions helps you tune your models for better performance. Gradient descent is a popular optimization algorithm used in model fitting. It works by iteratively adjusting model parameters to minimize the loss function. Think of it as taking small steps downhill on a landscape, always moving towards the lowest point. This process helps find the best fitting model parameters efficiently, especially in complex models like neural networks. Regularization is a technique used to prevent overfitting by adding a penalty to the loss function for overly complex models. Common methods include lasso and ridge regression. Regularization encourages simpler models that generalize better to new data, making your predictions more reliable and robust. Cross-validation is a method for assessing how well your model will perform on unseen data. It involves splitting your data into multiple parts, training the model on some parts, and testing it on others. This process helps you get a more accurate estimate of your model's real-world performance and reduces the risk of overfitting. Hyperparameters are settings that control the behavior of your model fitting process, such as learning rate or tree depth. Tuning these parameters can significantly improve your model's performance. Techniques like grid search and random search help you find the best combination of hyperparameters for your specific problem. Choosing the right features is crucial for effective model fitting. Irrelevant or redundant features can confuse the model and reduce accuracy. Feature selection techniques help you identify the most important variables, leading to simpler, more interpretable, and more accurate models. Outliers are data points that don't fit the general pattern. They can have a big impact on model fitting, sometimes skewing results or leading to poor predictions. Identifying and handling outliers, either by removing them or using robust models, helps ensure your model is accurate and reliable. Scaling and normalization are preprocessing steps that adjust the range of your data features. This is especially important for algorithms that are sensitive to feature scales, like gradient descent. Proper scaling ensures that all features contribute equally to the model fitting process, leading to better results. Missing data is a common challenge in real-world datasets. Ignoring missing values can lead to biased or incomplete models. Techniques like imputation or removing incomplete records help you deal with missing data effectively, ensuring your model fitting process remains robust and accurate. Understanding the coefficients or parameters of your fitted model can provide valuable insights into the relationships between variables. In linear models, coefficients show how much each feature contributes to the prediction. Interpreting these values helps you explain your model's decisions and build trust with stakeholders. Residuals are the differences between your model's predictions and the actual values. Analyzing residuals helps you spot patterns, outliers, or areas where the model isn't performing well. Good residual analysis is key to refining your model and improving its accuracy. The complexity of your model affects how well it can fit the data. Simple models are easy to interpret but might miss important patterns. Complex models can capture more detail but risk overfitting. Balancing complexity and flexibility is crucial for effective model fitting. Ensemble methods combine multiple models to improve prediction accuracy. Techniques like bagging, boosting, and stacking leverage the strengths of different models, often outperforming single models. Ensembles are powerful tools in the model fitting toolkit, especially for complex or noisy data. Choosing the best model involves more than just accuracy. Other criteria include interpretability, computational efficiency, and scalability. Sometimes, a slightly less accurate but more interpretable model is preferable, especially in fields like healthcare or finance where understanding decisions is critical. Automated machine learning tools can streamline the model fitting process, handling tasks like feature selection, hyperparameter tuning, and model evaluation. These tools make it easier for non-experts to build effective models, but it's still important to understand the fundamentals to interpret results correctly. Model fitting isn't just a technical process, it also has ethical implications. Biased data or models can lead to unfair outcomes. It's important to check for bias, ensure transparency, and consider the impact of your models on people and society. Model fitting is used in countless real-world applications, from predicting stock prices and diagnosing diseases to recommending products and optimizing supply chains. Understanding the fundamentals gives you the tools to tackle a wide range of practical problems and make a real impact. The field of model fitting is always evolving, with new algorithms and techniques emerging regularly. Staying up to date with the latest developments helps you build better models and stay competitive in the data science landscape. Continuous learning is key to mastering model fitting. Even experienced practitioners can fall into common traps like overfitting, underfitting, or misinterpreting results. Being aware of these pitfalls helps you avoid mistakes and build more reliable models. Always validate your assumptions and double-check your work. Documenting your model fitting process is essential for reproducibility and collaboration. Clear reports help others understand your decisions, replicate your results, and build on your work. Good documentation is a hallmark of professional data science practice. After fitting and validating your model, the next step is deployment, putting your model into production so it can make real-world predictions. Deployment involves integrating the model with applications, monitoring performance, and updating as needed. This step turns your analysis into actionable results. Once deployed, it's important to continuously monitor your model's performance. Data can change over time, and models may need retraining to stay accurate. Regular monitoring ensures your model remains effective and continues to deliver value. As new data becomes available, retraining your model helps it adapt to changing patterns. Regular updates keep your model relevant and accurate, especially in dynamic environments like finance or e-commerce. Retraining is a key part of the model lifecycle. Effectively communicating your model fitting results is just as important as the technical work. Use clear visuals, concise explanations, and tailored messages for different audiences. Good communication ensures your insights are understood and acted upon. Mistakes are part of the learning process. Analyzing where your model fitting went wrong can teach you valuable lessons and help you improve future projects. Embrace errors as opportunities to grow and refine your skills. Curiosity drives innovation in model fitting. Always ask questions, explore new techniques, and challenge your assumptions. Staying curious keeps you engaged and helps you discover better ways to solve problems. There are many resources available to deepen your understanding of model fitting, from online courses and textbooks to tutorials and community forums. Take advantage of these tools to expand your knowledge and stay up to date with best practices. Let's recap what we've covered. Model fitting is about finding the best mathematical relationship between inputs and outputs. It involves choosing the right model, preparing data, evaluating performance, and avoiding common pitfalls like overfitting and underfitting. Mastering these fundamentals sets you up for success in data science. As technology advances, model fitting will continue to evolve, with new algorithms, automation, and applications emerging. Staying adaptable and open to change ensures you remain at the forefront of this exciting field. The fundamentals you've learned today will serve as a strong foundation for future growth. Model fitting is both an art and a science. It requires technical skill, creativity, and a willingness to experiment. By mastering the basics, you'll be well equipped to tackle real-world problems and make a meaningful impact with your data analysis skills. Now that you understand the fundamentals of model fitting, consider applying these concepts to your own projects. Practice with real datasets, experiment with different models, and keep learning. The more you practice, the more confident you'll become in your model fitting abilities. Thank you for joining us on this journey through the fundamentals of model fitting. We hope you found this overview helpful and inspiring. Remember, mastering model fitting opens the door to countless opportunities in data science and beyond. Keep exploring, keep learning, and best of luck on your data journey.